Hi, I'm Dr. Califf, and today I'd like to talk about the machine learning metrics accuracy, precision, recall, and F1. The idea behind all of these is that we want to measure how well our model is actually learning. We need to know whether it performs well enough to be useful. We also want to know typically how it compares to other models. Is our model working better or worse than other options that we might have? The obvious choice here is often accuracy. Accuracy is the simple number correct over number attempted. So we're trying to do some task, we do 100 of them. How many did we actually get right? This is a familiar concept from school, from pretty much our earliest days. Your typical spelling test, you have maybe 10 words you need to spell. You got 9 of them right. You were 90% accurate. This works very well for many machine learning purposes. In many cases, we can just go with accuracy and we're happy. It's simple, we're good. But there are some cases where accuracy just isn't good enough. Consider an information retrieval problem. In information retrieval, we have a certain number of documents or files that we're searching in, and we have some sort of query. So suppose in one particular case, we should retrieve 3 particular files for this query. If we don't actually retrieve any files at all, what's our accuracy? Well, we had 1,000 things that we attempted, and we got 997 of them right. We correctly ignored 997 of the files. We had 3 of them that we shouldn't have ignored, but we also said were not things we should choose. And so we were 99.7% accurate. In another case, perhaps we have that same information retrieval problem, those same 1,000 files, same query that should retrieve the same 3, but we retrieve 3 incorrect files this time. Our accuracy then is 99.4%. We are getting this problem, at least what we care about in this problem, completely wrong. But accuracy says that we're doing pretty well, extremely well. There are some other cases where accuracy may be misleading. Quite a few other text processing tasks like information extraction, where again we're likely to label all the different words or tokens, and there are only a few of them that are of interest to us. Or consider recognizing a rare disease. We have a test. We're really not interested in all the people that it correctly says don't have it. We're really just interested in the people that we say do have it, or the people who do have it that maybe we didn't get right. Basically, any problem where we have very unbalanced classes, where the class we really care about is much smaller than the class of things that we don't. So how are we going to solve this problem? How are we going to go from accuracy right over right plus wrong, which isn't working for us, and turn it into some metrics that really do work for us? We're going to start by breaking down our right and our wrong answers. So we're going to turn right into true positives and true negatives. For all the things that we got right, how many of them were that class we're really interested in, the little one, which we'll call positives, and the ones that we expect to get right, the big class of things that we don't really care about as long as we get them right. Then we're going to do the same kind of thing with wrong, and we're going to say, okay, these are the things that we labeled as positive that were really negative, the false positives, and the things that we labeled as negative that should have been positive, because we're interested in all of that. So then when we start looking at what we care about, we really care about those true positives. What did we really get right that we cared about? And we want to look at it in relation to false positives and in relation to false negatives. So then we end up with a couple of metrics. The first one's precision. And what precision is asking is, out of the things that I picked, that I labeled as positive, how many of those were actually correct? That formula would be true positives over the sum of everything that I labeled as correct, the true positives and the false positives. Then we have recall. Out of what I should have chosen, how many did I choose? So once again, we have the true positives as our numerator, but this time we're dividing between the total number of things that we should have picked as positive. So let's see how this is related to what we've done. So the second version of our information retrieval problem where we picked 3 wrong files. In this case, our precision is 0. We picked 3 things, they were all wrong. We have 0 true positives and 3 false positives. Recall is also terrible. We were supposed to pick 3 things. We didn't pick any of them. Precision and recall are very accurately indicating we got the problem completely wrong, as opposed to our accuracy measure of 99.4. Suppose instead that we picked 4 documents, one of which was correct. In that case, our accuracy is 99.5% because we got 5 things wrong. We missed 2 of the things we should have picked, and we picked 3 things we shouldn't have picked. Our precision is 25%. We had 1 true positive. We picked 4 total documents, 1 true positive, 3 false positives. Our recall, out of the things we should have picked, we picked 1 true positive, 2 false negatives. So that's 33%. This gives us a much better sense of how we're doing on the problem we're trying to solve. There is a problem with precision and recall, however, which is we still want to be able to do things like compare. The 2 numbers allow me to look at the system and decide, does it work well enough for my purposes? Do I think the precision and recall are good enough? But when it comes to comparing, we have 2 different values. So suppose we have system 1 that's 20% precision and 90% recall, and system 2 has 70% precision and 60% recall. How do I decide which is best? We need some way to turn precision and recall into a single value that we can use for comparison. Obviously, there are multiple ways that we could do this. The standard way to do it is something called F1. It's a way to combine precision and recall. Specifically, it's the harmonic mean of precision and recall. So there are several different ways you can take a mean of numbers. One of them is the one we're most familiar with, the arithmetic average, where we just add them up and divide by the total. Then we have geometric mean. The harmonic mean formula is going to be 2 over 1 divided by precision and 1 divided by recall. So the inverse of precision and recall. Or we can simplify that into 2 times precision times recall over precision plus recall, which is the version of the formula that you'll typically see, since that's the one we almost always actually plug in to our code. One advantage of the harmonic mean is that it encourages the 2 values to be similar, and most people believe that precision and recall probably should be somewhat similar. Now, there are cases where we don't care the same amount about precision and recall. We might be more concerned about precision, about not having false positives, and less concerned about false negatives. Or we might go the other way, where we really care about recall, we don't care as much about precision. So it turns out that with the harmonic mean, we can use a beta parameter to weight it. What that looks like is 1 plus the beta parameter squared times precision times recall over the beta parameter squared times precision plus recall. If beta is less than 1, then precision will be favored here. If beta is greater than 1, it will favor recall. Typically, if we want to prefer precision, we're going to use a beta of 0.5. And if we want to prefer recall, we're going to use a beta of 2. So real quickly, I just want to go back over the formulas that we talked about to give you a single slide that has them all. Average, we're familiar with. It's the correct things over the sum of all the things, right and wrong. Precision, we're interested in those true positives divided by all of the things we chose as positives, so the true positives and the false positives. Recall, we're interested in the true positives out of all of the things we should have chosen. So the true positives plus the false negatives. And finally, we have F1, 2 times precision times recall, over precision plus recall will give us a single value that does a pretty good job for allowing us to compare systems with precision and recall. I hope you found this helpful. I appreciate you watching. If you got something out of this content, I appreciate likes and subscribes to help other people find it.